All right, here we are for day 12 of the Advent of Code 2020 challenge in C#. Yesterday was okay. It did take me forever, but I had a general solution. There's probably a ton of things I could have done to speed up my time. Build the grid a more coherent fashion, so I wasn't, creating all these abstract conditions to figure out what's going on. Yeah, but it's fine. I was actually thinking about this a few minutes ago, and this actually reminds me of this other problem called the n-queens problem. I don't remember the exact rules, but it was something like you have a number of queens on a chessboard. Queens can go in any direction as far as they want. And you kind of have to figure out like the positioning of those queen pieces given a certain number of queens already on the board. Without them being in like attacking distance. So just like what we did here, where we kind of on part 2, where we had to figure out like, what are all the adjacent occupied seats in a diagonal, horizontal, vertical space. It's kind of like the n-queens problem, which is, I guess, like a first order logic kind of problem. Kind of like Sudoku, where you have, a list of rules, and it's really about figuring out a model that fits all the constraints. Which is interesting. I wonder. I did think that yesterday was going to be a path problem, but it was a 2D problem. I was 30% right. But it would be interesting if this turned into a constraint problem that followed on off of the seating problem. We did already have 2 seat problems. Finding our seat on the plane and then finding our seat on this, what is it? A ferry? A ferry to a tropical island. It sounds kind of weird, but yeah, okay. Alright, so I'm set up for day 12. I've got my stuff, and I'm ready. Alright, we're making progress. Ferry needs to take evasive actions. Oh, look, here's the storm. Unfortunately, ship's navigation computer seems to be malfunctioning. It produced extremely circuitous instructions, and the captain uses the PA system. The navigation instructions consist of a sequence of single character actions paired with integer input values. Action N means north, south, east, west. Action L means turn left the given number of degrees. Interesting. Turn right, given number of degrees. F means move forward by the given value in the direction the ship is currently facing. Okay. So we can move in the cardinal directions, but we can also move our ship by degrees. The ship starts by facing east, so facing to the right. Only the L and R actions change the direction the ship is facing. That is if the... Okay, I got that. For example, these instructions would handle as follow. Forward 10, north 3, forward 7. So forward 7 would take us in east. Right 90 would turn us down. F11, go 11 down. So we find the ship's Manhattan distance, which is the sum of difference of dimensions. from its starting point is 25. Okay. Figure out the navigation instructions. What is Manhattan distance between the location and the ship starting point? Alright, so like what I normally do, let's start with some sample data. So we're going to parse this, and we need I guess our command and our digit. So what do we want? A list of tuples of character and integer. That should be fine. Let's call this commands. So for each line, we're going to say I guess we can do this. Now use our buddy link. So character 0 is going to be our character. And what do we want? We want a integer. So parse will you stop with this? Okay. D dot substring of start index of 1. One more parentheses. Send that to a list. And voila, we've parsed. So let's check that out, see how that looks. And I move this to the side so you can actually see when I'm looking at these locals. So commands F10, N3, F7, looking good. So we need to move in the directions. So we're going to have a what would we call this? Heading? So we're going to start with a heading of 0, which is facing east. Right, and then adding degrees will spin us clockwise. And then we have a X position and a Y position. Yes. So what are we going to do? We're going to go through each command. One. So if we get north, this is kind of the pitfall we got into yesterday. Moving directions can be a bit confusing. So if we go north, we're going to go minus. Minus will take us up. Y. Minus equals command.item 2. Let's see. What are you unassigned? How about now? Okay, it's happy. All right, there's north. Let's go south. So we're going to add our value. We can go east and west. So east is to the right, so that's going to be x plus. West is to the left, that's going to be x minus. Never eat shredded wheat. If we're going to go forward, that's going to be... So is our... Are we always going to turn in 90-degree increments? Whoops, whoa. I did not meant to hit the submit button. R, 180, 90, 90, 180, 270. So yes, we will always turn in 90-degree increments. So if we get F, we need to move in our heading. So let's just say this. Our heading equals E. Right now, what do we want to do for heading? I guess that's fine. Alright, if heading equals 0, no, we are not in Python. If heading equals 0, how can we simplify this? How about we do this? We're going to say, we're going to have this function called move. And it's going to give us, we're going to give it a x, y coordinate in a direction. We're going to move this guy up here. Direction, direction, direction. And we're going to have I guess special case for F, R, and L. Oh, and length, I guess. Or maybe distance. I guess we call this distance. All right, so that's move direction. So let's change our heading to how do we want to do heading? I guess it can be 0. Let's do this too. Get direction, integer, heading. And we'll figure out the heading from here. So if heading equals 90, heading equals 0, return east. So 90, we're going down. 180, we're going west. And 270, we are going north. Otherwise, throw an exception. Okay. New exception. Okay. All right. So if command equals R, we're going to say our heading equals heading plus item 1. Heading is going to be positive, so command.item 2 and modulus 360. So if we get to 360, it should be a 0. If we get past it, it should be, 90, 270, whatever. If the command item 2 equals left, we're going to do the same thing, except it's going to be a minus. Ooh, let's throw in also this. Is that right? Minus. So if I'm at 270, no wait, if I'm at 0 and I go negative 90, I actually want 270. Can I do that? Bool to int. What? Yes, I want a ternary. Why would heading 0? Okay, let's do this first. Oh, because I need a... I'm doing the ternary wrong. I don't know why I wrote that. Question mark first. So, there we go. And do we still want the absolute? So if we had 90 and we got 180, I guess we can add 360 to make sure this works out. All right, commands dot item 1. I see you saying item 2 up there. If item 1 equals F, then we are going to, let's see, xy equals move xy, get direction of heading, and command dot item 2. It's a bit confusing, but it is what it is. Cannot convert type. How about like this? Is that how you do it? Yes, that's how we do it. Else move. Whoops. We're going to move, instead of in heading, we're going to move whatever item 1 says, which is that direction. All right, so once we've moved around, we should have X and Y. And we just need X plus Y. We don't need to subtract it from 0. Convert this to a string. All right, do you work? 25. Hey, look at that. I'm not even going to check it. $381. Wow. We're moving along. All right, part 2. Before you can get the destination, the captain realized that actual action meanings were printed on the back of the instructions. Action N means move to the waypoint north by the given value. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. Okay, so we need to track a waypoint. L means rotate the waypoint around the ship. Ooh. Around the ship. As in, like a loop. X and F means to move forward to the waypoint a number of times equal to the given value. The waypoint starts 10 units east and 1 unit north. Okay. The waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it. Holy cow. F10 moves the ship to the waypoint 10 times. So how do we figure out? I think I get it for, the cardinal directions. The left and right, I'm not so sure. Counterclockwise. R rotates the waypoint around the ship clockwise 90 degrees, moving it to 4 units east and 10 units south of the ship. The ship remains east 170, north 38. Okay, so I have a baby level of math. How do I figure out the movement along this circle around the ship? I assume it has something to do with pi. Let's do some Googling. Find position along circle. So let's see, Google says that a point at angle theta on the circle whose center is x0, y0, and whose radius is r, is x0 plus r cosine theta, y plus r sine theta. Now choose theta values evenly spaced. So choose theta values evenly spaced 0 to 0 and 2 pi. So theta is our, oops. So let's see, we need a calculation for moving it along this circle. So we need to get the distance between the ship and the circle, or the ship and the waypoint, which is just that Manhattan distance. I assume we're doing everything in Manhattan distance. Will a cosine still work? I hope so. So let's see. X1, Y1, X2, Y2, which is basically just this guy right here. X1 minus X2, Y1 minus Y2. And then we also need a function that says move waypoint let's see, what do I need to do? Move waypoint around? Yes. So X and Y is going to be our waypoint, right? No, X and Y is going to be our ship. And then we need a direction. We need a heading. So X2, sure, we'll call this X2. X2 is going to be our, we need distance, which is, I guess, going to be our radius. So distance times cosine of our heading plus our ship, right? Ooh, I wonder how this is going to work with using Manhattan distances with, you know, something that's not Manhattan distance. This needs to be sine x2, y2. Okay, so that's how we move the waypoint around. So we also need to move the waypoint at the same time as we move the ship. north means move the waypoint north. So we're only going to move the waypoint with the cardinal directions. And we're only going to move the ship with left, right, forward. But when we do left, right, forward, we're also going to move the waypoint along with the ship. So let's see, F7, move the ship to the waypoint 7 times, leaving the ship at east and 38. The waypoint stays 10 units east and 4 units north of the ship. Okay. So we're going to start with, let's just call this ship X and ship Y. And waypoint X and waypoint Y, but waypoint X and Y needs to start at 10 units east, so plus 10 to the right. 10 and 1 unit north, so -1. All right, and so let's start eating through our, well, we also need a heading. So I guess we're going to be facing east still. Okay, let's go back to our test instructions. Create command and commands. Let's see. So if let's do a bit of copy and paste here. So if we move to the right, we want to move our waypoint around. So we're going to get our radius by saying get distance between the ship X, ship Y, and the waypoint X, waypoint Y. That's going to give our distance, and then we're going to say waypoint X and waypoint Y is going to move waypoint around the ship at a distance of command item 2 and a heading of heading. Given number of degrees. So this isn't going to be heading, this is going to be wait, distance. What am I doing with distance? Move waypoint around. Distance times. Oh, this is not distance. This is R. And then the heading is what we get from the command. Okay. And then we're going to do the same thing. Ooh, but we need to go to the left. How do we do that? What? Why would R and L matter? Counterclockwise or clockwise? So if it was clockwise, we would just give it whatever the heading is, right? If it was counterclockwise, we would say the heading is the opposite direction of what they gave us. So instead of command 2, we're going to say, we don't need this heading up here. We're going to say the heading is item 2 plus 360. No, wait. $360 minus item 2, right? So if they gave us left to, they wanted us to turn counterclockwise 90 degrees, it would be 360 minus 90, which is 270, which would send us north. Heading. All right. Command forward. What do we do for forward? Move forward to the waypoint a number of times equal to the given value. You know what? We don't need... What am I doing here? Why am I calculating cosines when it's simply just distance and then... You know, I'm curious if this would even work. Let's see, so command, so we're going forward, north, forward, right. Okay, so right, we're at a distance of 11 Manhattans. And we're moving the waypoint to -4 and 9. Moving it to 4 units east and 10 units south of the ship. So the ship is at 0, 0. 4 units east and 10 units south of the ship. So yeah, actually this is actually working. Okay, so super weird. Forward is moving in the direction of the waypoint. So I guess we can do another function here. Get waypoint's direction and ship, let's call it ship X. Ship Y and waypoint X, waypoint Y. And to figure out where it is, we need to say, you know, if the ship is to the left of the waypoint, then we need to return west, right? If the ship is to the right of the waypoint, no. If the ship is to the left, it needs to go in the direction of the waypoint, which is to the right. This would be west. If the ship is north of the waypoint, then we need to move south. If the ship is to the left of the waypoint, no, not left. The ship is below, we need to move north. All right. All right, so if it's forward, we need to say ooh, we need to do a double movement. Where was our function? So we had this guy up here, which was move. We don't want the ship's position, right? We want the offset. Which I guess we can do something like this. Get offsets. Ship X. Whoops. Copy this guy. So we're going to return ship X minus ship waypoint X. And ship Y minus waypoint Y. So what are we going to do with those offsets? We don't want the ship's offsets, we want the waypoint's offsets, right? So let's say offset X, offset Y, offset X and Y equals get offsets, ship X, ship Y, waypoint X, waypoint Y. And then we're going to move our ship. Our new position is going to be move. We're going to move ship X, ship Y. Our direction is going to be get, what did we say? Get waypoint direction. Ship X, ship Y, waypoint X, waypoint Y. And our distance is going to be what the command says. Oh, so we moved our ship, and now we also need to move our waypoint. So waypoint X plus equals offset X, waypoint Y plus equals offset Y. I'm not sure if that's correct. All right, so if it's a direction, we need to move the waypoint. So for that, we simply just say waypoint X, waypoint Y equals move waypoint X, waypoint Y. Direction is our command, item 1. And our distance is item 2 of our command. And once we've done all this nonsense, we will get distance of, what are we getting the distance of? So we can just do this again. Oh, ship a distance of 6. That is not correct. F means to move forward to the waypoint a number of times equal to the given value. F10 means move the ship to the waypoint 10 times. A total of 100 units east and 10 units north. So, no, not this guy. This guy needs to move this distance, which is item 2, times the distance between the ship and R, right? Action F means move forward to the waypoint a number of times equal to the given value. F10 moves the ship to the waypoint 10 times. A total of 100 units east and 10 units north. That's... The waypoint stays. Okay. So this offset is incorrect. It should be the waypoint is offset by the ship Y plus ship X let's see. We need to get the distance between the waypoint and the ship to figure out, and we're going to move that distance by product of whatever value we get from the command. Waypoint X. I'm not sure about this. Alright, first they move forward 10 times. So the ship should be at, it says 110 by 0, which is not right. The ship should be at 100 by 10, right? Ship Y, ship X, ship Y. So we got to F. Our offsets are 10 and -1. Okay. This should be an absolute. No. Should it be? All right, we get our offsets. Our distance is 11. We're going to move the ship, but the ship... $10 and -1. So we shouldn't... The waypoint is not directly above, below. It's at a degree heading. So we need to get... We don't move this way. We need to move toward a heading. Which is just the offset 10 times, right? Let's see. Offset x times command dot item 2 and y is going to be $10 and -10. 10 and -10. $100 units east and 10 units north. North, up, negative. Okay. Leaving the ship at east 100 and north 100. The waypoint stays 10 units east and 1 unit north of the ship. So the waypoint is 10 units east, which is to the right, and 1 unit north, which is negative. Okay. What do we got? 198? No. Okay, so we got forward down. What else do we have? This is north. We're going to move the waypoint north. So the new waypoint is at 110 and -14. Moves the ship at... The ship remains at this position. The waypoint is... Moves the waypoint 3 units north to 10 units east and 4 units north of the ship. 10 units east, right, and 4 units north. Correct. Okay. What do we do? We're now moving forward 7. So our... F7 moves the ship to the waypoint 7 times, a total of 70 units east and 28 units north. We moved 70 and 28 units north. Leaving this ship at least 170 north through 38. Okay, we got that right. So maybe it's the rotation that's not right. So we rotated the waypoint, moving it to 4 units east and 10 units south of the ship. So 170, 4 units east. So it should be 174, but instead we have 163. 4 units east and 10 units south of the ship. Okay, so the rotation is not right. We should, when we rotate, we should get 174 in negative, what did that say? 10 units south of the ship, which would be negative 30, negative 28. Okay. Let's look at our rotation again, which was where? Over here. So we're moving to the right, we're moving clockwise. So our heading, oh, what am I doing? Get distance. I need to get heading. I need to get the angle between the ship. Why did I get distance? Anyway, get heading. Let's copy our ship XY stuff. So let's see. First, we'll get our how do we move positive or negative? So let's see. What is our calculation? ATAN? So we want the difference between the ship and the waypoint. And then we take that and we do this, what, ATAN 2? XDiff, YDiff times 180 divided by pi hopefully that turns into a pretty integer. If not, I will be sad. Alright, so R needs to be Oh, wait. What am I doing? Means to rotate the waypoint around the ship right clockwise the given number of degrees. Hmm. So we need to get... Oh, we need to get... So we do need heading. We need to take the command new heading equals, let's see, get heading of this stuff. And we need to add or subtract. So if we're going right, we're going to add the command dot do modulus 360, and that should be our new heading. Yeah, let's try this out first and then fix right or fix left. So we got 156 and negative 38. Okay. What did we have before? 180 and negative 42. $156 and negative 38. It's not what we should have for this. The command is right 90 degrees. Four units east, 10 units south. What was the current heading? Current heading was negative 68. Negative 68 degrees. Okay, so it really should have been is that correct? Negative 68, which should be plus. So negative 68 would take us something like almost 270 or a bit more. New heading is 22. Current heading is 292. New heading is 22. Right, 90 degrees to the right of 292. It still sent us 156 to negative 38. Move waypoint around. Which was, we give it our ship's position, we give it the distance of the ship and the waypoint, and we give it a heading. So does that make sense? 292, the new heading is 22 degrees from this ship. So 22 degrees is east, southeast. Which, yeah, should have been greater than 170. So the heading looks correct. The move waypoint around function does not look correct. Radius times cosine of heading plus the ship position. Distance. The distance would be the radius. The heading should be correct. Current heading is 292 degrees. So a little bit somewhere between west and northwest, I guess. So that should be, ooh, I think I have that wrong, because ship X is 170, waypoint is 180. That should mean it's 10 to the east. So our current heading should be northeast, but we got northwest. Get heading. Now, what did I get before? I got like a heading of negative 68. Now, what is that? Is that negative 68 from north? Negative 68. I should have bet that's negative 68 from east. 292. No, that's correct, because 270 is north. And 292 would be northeast. I had that wrong. So 292 is right. New heading is 22, which should move us to the right and a bit down. Now move waypoint around. Does maybe the heading, I wonder what it expects for this data value. $176 and negative 50. Four and 10. East, 10 units south. 10 units south would be positive, right? $118.42. Oh, it would help if I went to the right breakpoint. $176 and negative 25. So this one is close. Let's change get heading to, let's return a double. And move waypoint around. Let's use a double here. So our new heading, 178 and negative 26. It's close. It's close, but not right. Why am I trying to move around? All right, for get distance, maybe we need to get the exact distance, which is what, square root of the difference of dimensions. where was my distance? Let's double, so let's return a math power of 2 power of 2 and then square root. So we're gonna say, what did I call that? Get distance exact. Let's try this. Move waypoint around, change this to a double. $176 and 29. Yeah. This isn't working out. Rotate the waypoint around the ship right clockwise the given number of degrees. So it should move from 291 degrees from the ship to 21. What am I doing here? Oh, does the heading need to be in radians? Hmm. Two radians. Angle T in radians. How do I calculate get radians C#? Help me out, Google. What? What is this? You know what? Let's copy and paste from the internet. It's never let me down. Um, negative. It moved the waypoint up 2. Four units east and 10 units south of the ship. Hmm. Hmm. Retrieve angle between 2 points. Now, let me just mess with a few things. So we were to the right and north. Hmm. No, 111 is not right. We had the correct value. Current heading -68. Which is right. Because we are, yeah, to the right and above. Yeah, I was on a roll, but then they gave me basic trigonometry, and apparently that's a bit too much for me. We got a bad order. Should really call this radius. Cosine and then sine. Yeah, it doesn't matter. What is it doing? It's going down. It's going directly south. That can't be right. I want a new heading of 21. Which should be slightly east and down. Actually, I think that actually looks right. But this says moving at 4 units east and 10 units south of the ship. We're actually the exact opposite of that. We are 4 units east and 10 units south. We are 10 units east and 4 units south. Y. X, Y, ship X, ship Y. Wow. Why is that correct? $286. I have no clue why that's correct. Alright, but for moving left, I wish they put something in here to explain left. Explain left. How did we do it before? To move to left, it was heading minus item 2. So we need current heading minus item 2. Heading plus 360. Okay. All right, we got some big old number. That's not right. How do we test this? So let's say, let's just have one. I want to move left 90 degrees. And I'm going to put our starting guy only 10 units to the right. So we want to move left 90 degrees, which should put the waypoint 10 degrees north. Oh, what's going on here? Heading equals 360. Ooh. Oh. $100. Why 100? What? Well, it moved in the correct position, but what? Where did this 100 come from? Yeah. Oh. Let's see, we want, so okay, we're currently 10 units east. If we rotate 90 degrees to the left, we should be 10 units north. Correct. Okay. Puzzle input. Negative. Why do we have a negative number? Oh, did we overflow? Uh-oh. Yeah, it should be impossible to have a negative number. Right? Integer to string. So, okay. We need to start changing some data types. Yeah. So get distance needs to change. How about we do this? Let's just go nuts and change all the integers to longs. Okay. That is a gigantic number. It's not the right answer. Your answer is too high. Okay. That's reasonable. It is a gigantic answer. Are we getting the test information correct? $292. We've somehow started to get a wrong answer. What happened to our correct 286? Well, let's step through this again. Alright, go forward 70. So our ship's at 100 and... Oh, dang. I forgot I changed that for testing. Alright, back to our 286. What are you doing way over here? Ooh, that is way super high. Oh, I don't want to put that number in. So it could be that our left is still incorrect. We did test it out though, right? Left's 90. So that moves our guy to basically north. One to the right and north. Or one to the left, I mean. Let's see. F11 moves the ship to the waypoint 11 times. Move forward to the waypoint a number of times equal to the given value. I mean, we have the test movement correct. I wonder what's wrong with the actual input. So we have this. So move west 3 means we're going to move our waypoint. Waypoint is going to move west 3. So we should have WPX changed to what, 7? Yeah. Let's see, rotate 180 degrees to the right. 180 degrees to the right. That basically means that WPX should flip to -7, more or less. Huh, but instead, it changed to 7. So the current heading is -81, which is 7 and -1. The current heading should have been like 0. How? Why? $174. Okay. All right, what do we got? We're gonna move right to 180 degrees. Incorrect. Why do I have sine for x and cosine for y? Let's see, we're at 7, -1, 180 degrees to the right. It says the current heading is 278. Which is not right. The current heading should be 0. Current heading is 8, which is right. It's just that's slightly below east. New heading 180. And we've flipped. Okay, that looks a lot more better. Let's get our test data back. $198. We've moved 4 units to the left of the ship, which is 4 units west. Four units east, 10 units south. Current heading was 21. New heading is 111. So 170, 180 is to the right, and 42 is up. So the why is current heading 21? -42 is north, right? So the current heading should be something like -21. What did we do up here? We added 90. Hmm. Oh boy. This is backwards, isn't it? Current heading 158. Let's see. Now we'll get there eventually. Slow and steady, I guess. So, current heading is 158. We are to the right and above. So 158 does not sound right. What are we getting here? Are we doing the correct difference? -21. So that's, yes. There we go. That looks nice. Let's do the same thing with you. We don't want this, we don't need this 360 thing. All right, we're back to 286. What answer do we get now? Oh boy, that is a gigantic answer. There's no way it's that. All right, right 180 degrees. We should see WPX flip to -7. Current heading is -8. That is correct. New heading 171. Makes sense. And we see WPX flip. Right 90. Where are we? We are to the left and below. So we are almost, what, 180 degrees? Right, 160. The new one is 250. So we are going to the right, so we should be going north. So WPY, we are north. That looks right. Okay. 270. Let's test with something simple again. All right, we are currently pretty much due east. We want to move left 90 degrees, which will take us to 264. So our new position should be pretty much due north, right? And that's what we get. So why are we getting such a crazy value for this? You know, let's put it in just in case. Oh, that's no way. I don't remember it filling up the whole box like that. F7. F11. So move the ship to the waypoint 11 times, a total of 44 units east and 10 units south. $214 by 72. The waypoint stays 4 units east and 10 units south. So 4 units east, 218, yeah. And 10 units south, 82. It moves to the waypoint 7 times. Hmm. F7. F7 moves the tip to the waypoint 7 times, 70 units east and 28 units north. Let's see that occur just in case. F7, so we're at 100. We moved 70 units east and 28 units north. Yeah. Let's see. We go right 90 and then left 90. We should come back to the same spot, right? So here's our right 90. We move to 174, negative 28. Here's our left 90. We move to 182, negative 43. That's not where we were at. We were at 180, 42. So it fails the back and forth test. (174, negative 28). Left 90 degrees. Left 90 degrees, 338. Which is right. 68 degrees is kind of south. And negative 90 would take us to kind of east. But we get 182 by 43. Ah, I see you here. You're not using the get distance exact. Why are you even... Alright, so let's see if we can get back to 180, negative 42. There we go. That looks good. Darn left. This is why... Ooh, that looks a whole lot better. Nice. There we go. Ah, that was another slog. Oh, we're going back. Oh, this is interesting. I guess that's where our gaps were. We're doing some sort of loop or something. Alright, so the thing here was the key points for this problem were figuring out a point along a circle with the ship being the center. So we have this algorithm. And then also making sure we're using radians when they're needed. We're using the exact distance and not the Manhattan distance before calculating this waypoint thing. And when we're getting the angle between the ship and the waypoint, our ATAN calculation here needs to be Y first and then X. I should probably... So this is probably a hint to me to spend a bit of basic time with pi and, you know, circles. I'm sure they'll come in handy in some area. Probably in more like the GIS world, Geographic Information Systems. For basic stuff like this, I probably shouldn't need to look it up. But yeah, here we are for day 12. We are moving our way down the leaderboard. We did okay for the first part. We, yeah. Not knowing, you know, how to get stuff like the angles between points and, you know, point along a circle. That, yeah, it slowed me down quite a bit. The one thing that was confusing is that we were using non-exact points. We were using, you know, whole number for the XY coordinates, but we are calculating stuff like the points along a you know, along a circle, which is, you know, irrational numbers. That's probably just a thing about the question. I'm sure if we were doing this outside of this question, we would want our coordinates to be, you know, exact numbers, not whole numbers. There's probably a good chance that the question was set up in a way that moving along that circle would always get you to a whole number. Maybe? I mean, there was the weird thing where we were only moving in 90-degree increments. Oh, yeah. Yeah, since we were moving in 90-degree increments, we would always move to an exact position. We would need something like, you know, moving 1 degree or moving whatever. We probably didn't even need to calculate the cosine sine stuff along the circle, because it was really just you take the radius and add the radius to either xy or subtract it from xy. Oh dang, now that I think about it, yeah. The fact that we were always going in 90-degree increments meant it didn't matter what the degrees were. Boy, that would have saved me a whole lot of time. Yeah, we didn't need to do this. Our move waypoint along our move waypoint along would have just been we would change this heading to, you know, northeast, southwest, and, you know, if it was go north, we would move, you know, the waypoint basically the radius from the ship. So we'd move the waypoint to, so if the heading turned out to be, you know, go north, so we were starting at east, 0 degrees, and if we subtracted, you know, 90 degrees, our heading would then go, you know, go north. So our new waypoint position would be the position of the ship the offset between the position in the ship and then that offset of y minus the radius. Yeah. Something like that. So, another key point gotta kind of pay attention to is like, hey, we're moving only in 90-degree increments. We don't really need to care about the fact that, you know, the circle is a continuous thing. We're really just moving, you know, one radius up, down, left, or right, given the offset from the ship. Oh well. It doesn't change the fact that I do need to spend more time thinking about that sort of circle pi stuff. Alright. Well, that's it for this one. We'll, yeah, keep chugging along.